In this video, we are going to be dividing algebraic fractions. Now, you need to be familiar with dividing numerical fractions. So let's recap that first of all. I'm going to start with 1/4 divided by 5. Now, if I'm dividing something by 5, I'm effectively splitting this up into fifths. So I'm actually multiplying by 1/5. So the correct process here is to rewrite this question as 1/4 multiplied by 1/5. So effectively what we do is we replace the divide by sign for a multiply sign, and we reciprocate this fraction here. Well, this number, this actual 5 can be written as 5/1. So we're reciprocating 5/1 by 1/5. And then we just multiply the numerators. 1 times 1 is 1, and the denominators 4 times 5 is 20. So, starting with example 1. So I can now just rewrite this question as x over 4. And instead of divide by 5, it would be multiply by 1/5. So this time I'm timesing x by 1 to give me 1x, which is x, and 4 by 5, which is 20. Example 2. I'm going to rewrite this question. This is exactly the same as a numerical fraction, but I've got algebraic terms. So my first fraction, g over 4h, will remain as g over 4h. But this time I'm multiplying by 2h over 3j. And I can clearly see now that this h here will simplify with this h here. I can divide this by 2 to give me 1, and I can divide this by 2 to give me 2. So I'm left with g multiplied by 1, which is just g, and 2 multiplied by 3j, which will give me 6j. Example 3. So again, I'm going to rewrite the first algebraic fraction will remain as it is. So it'll be y divided by y plus 7. The divide by sign becomes a multiply, and the next fraction is then reciprocated, so the numerator becomes y minus 1, and the denominator becomes y to the power 4. I can then try and simplify this fraction further before I multiply it out. I can divide this numerator by y to give me 1, and this numerator by y to give me y to the power 3. So I can then multiply this one out. So I've got 1 times y minus 1, which is just y minus 1, all divided by, this time I'm multiplying y plus 7 by y to the power 3. And I'm multiplying y plus 7 effectively as an algebraic expression. So I'm going to put brackets around that. And then I can write my answer as y to the power 3 bracket y plus 7. Example 4. Again, the first algebraic fraction remains as it is. So this will still be x minus 4 over x plus 3 multiplied by x plus 3 over x minus 1. And I can see this will clearly simplify, because this will divide by x by 3, this will divide by x plus 3, so this will give me x minus 4 all over x minus 1. In these next two examples, press pause and try them yourself, and then press play to reveal the solution. So starting with example 5, I have replaced the divide by sign for a multiply by sign, and I have reciprocated the next fraction to x minus 4, x minus 7 over x plus 5, x plus 7. I can then see common factors of x plus 7 that will simplify. So I'm then left with x plus 4 times x minus 4, x minus 7 as my numerator, and x plus 5 multiplied by x plus 5, which is x plus 5 squared. And then a final step would be, I can actually expand out x plus 4, x minus 4, and that would simplify to x squared minus 4, because the 4x and the minus 4x would cancel out. So I'm left with x squared minus 4 times x minus 7 over x plus 5 squared. Example 6. Again, replacing the divide by sign for a multiply and reciprocating this next fraction here. I can cancel or simplify a p minus 3 here with a p minus 3 here, because I've got p minus 3 squared. This then leaves me with p plus 1 multiplied by p plus 1 over p minus 3 q minus 3. P plus 1 times p plus 1 simplifies to p plus 1 squared. and I can't simplify my denominator anymore. Example 7. Again, press pause and try it for yourself, then press play to reveal the answer. So, if we factorise x squared plus 2x minus 3, we get x plus 3x minus 1 over x plus 2. We then replace the divide by sign for a multiply, and we reciprocate this fraction here. So 5x plus 2 becomes the numerator, and 4x minus 4 becomes the denominator. I can then simplify x plus 2 here with x plus 2 here. So I'm left with 5 multiplied by this numerator here to give me 5x plus 3x minus 1, and then 4x minus 4 multiplied by the equivalent of 1 here, which gives me 4x minus 4. In this final example, example 8, there's quite a lot of factorising to do here. We've got this numerator and this denominator to factorise, and this numerator and this denominator to factorise before we can start to simplify. So press pause and try this question yourself, and then press play to reveal the solution. So I have split this question up into 3 parts. Essentially, we have to factorise, that's the first part, by factorising the expressions, numerators and denominators. We then have to change the question to a multiply, and we then simplify. So starting with the factorised part, I can factorise x squared plus 4x minus 5 into x plus 5x minus 1, and again you should be familiar with factorising. I've factorised my denominator here to x minus 3x plus 1. I've factorised this numerator here to x minus 3x minus 1. And I've factorised this denominator here to x plus 5x plus 1. So that's the first step. The next step is to change this divide by sign to a multiply and reciprocate this fraction that we're dividing by. So effectively the denominator becomes the numerator and the numerator becomes the denominator. The third step and final step is to do the simplifying. So I have to look above and I have to cancel common factors. So I've got x minus 1 here, that will simplify with x minus 1 here. I've got an x plus 1 here, which is simplified with an x plus 1 here. This means I'm then left with an x plus 5 multiplied by an x plus 5, which I can write as x plus 5 squared, and an x minus 3 multiplied by an x minus 3, which is x minus 3 squared.